So I picked this bike up a couple of weeks ago. Customer complaint was he takes it up the road, it dies on him. When we brought it back, the battery was flat. Charged it for a couple of hours, got the bike running. When sorted some stuff out while it was warming up, came back, bike stopped running. Lights are still on. Went to start it again, battery was flat. So we naturally thought that where it stalled, the light stayed on and drained the battery. So the battery back on charge again, got the bike going again. And the past couple of weeks the weather's been atrocious. It's been cold, windy, wet, so I didn't get a chance to road test it. And ironically, every time we came back to it, the battery was flat. So on Saturday I came in again, charged the battery up, got it running again, and it literally stopped in front of me while I was standing there. Went back to start it, battery dead. So now we're going to run some tests and see where we're getting these issues and problems and what's causing this sudden stopping and sudden battery loss. I'm at the bike now, battery's gone flat again, so I'm going to substitute this battery with a jump pack so we can do our tests. I haven't got time to stand around for another couple of hours charging this one up. So we can use it as a substitute battery and then we can get the bike going. As of right now, trying to start it, battery's dead. I'll turn the jump pack on. So the bike runs. I'm going to start it up again. I've got my multimeter here. I'm just going to see if there's anything coming out at the battery, charge-wise. So as you saw there, we had 12.5 volts with the jump pack on. As soon as I turned it off, it dwindled down to 7.5 volts and the bike cut out. So we have no charging. So we need to look at the charging system. I'll start from the regulator rectifier and work my way backwards. I'm going to test the generator directly and see if we've got any AC voltage coming out of that. The battery is DC voltage, but the alternator is AC voltage. Hence the phrase alternator, because it has alternating current coming out of it. So we'll get the bike up, I'll get to the plug, we'll power the thing back up again and we'll run our tests from there. We've got the generator behind this cover. The cable comes out the back all the way through to here. It goes underneath the seat. So I've unplugged it. So these are 3 wires here. These are the 3 phases from the generator. It's a 3-phase generator. So when I start the bike up, in theory we should have AC voltage coming out of these. Normally on idle it's about 12 volts, and the higher you rev the bike, the higher the voltage. You can get anything between 70 and 100 volts the higher you rev it. So I don't need to rev it, I just need to start it up and see if I can get anything out of this at idle. So I'm looking for around 12 volts. Right, you saw there, nothing coming out the generator. There was a couple of little volts fluctuating on there, but you can create AC voltage by just shaking some wires around. So whatever number you saw, trust me, it was 0. So we don't need to check the regulator, because up to the regulator there's nothing going in there. So our next step is to work our way backwards to the generator and see if there's a problem in here. So this is supposed to hold all the magnets in there. We can see where the problem is. All the magnets are stuck on here. So these are all our replacement parts. Got a new rotor, a new stator, and we're going to replace the regulator rectifier. This is an uprated one with MOSFET technology in there. This may be in good condition, but if we look at the evidence, this has got a plastic ring in here. Just about to see it in there. So the plastic ring is holding the magnets in. If we look at the plastic rings that have come out of this one onto here, we can see they're all melted. So something has caused this to overheat. Now it could be that this was the cause of it. So to make sure that everything is going to work properly, because these things are not cheap. It's over £1,000 worth of parts here. So to make sure that we don't end up in this state, is we're going to change the whole thing as one unit. I've just charged the old battery up. I have a new battery here as well. Just going to do a quick battery test with this. I have a battery tester here. Let's see if I can show you there. This particular tester does cars, trucks and motorcycles. So we click on motorcycle. All motorcycle batteries have an identification code on there. So this one is YTZ10S. This particular tool has all that information in it. So we don't have to put any of the figures from the battery in, you just scroll up to the code. So we can just see there. So we've got YTZ10S, which is the same code as this. So we click on that. It asks you several questions. It's outside of the vehicle, yes. Is it an AGM? Yes. This particular machine tests by using the temperature of the battery as well, so it's more accurate. So we're going to capture that now. And after charging it, it's coming up as good. So we'll put this one back in the motorcycle. Once we put all the other bits in, we'll run it up, see what it's like, and then we'll do another test again and make sure it's okay. A little bit earlier I showed you how I tested the power coming out of the stator. Now I'm going to show you how to test a regulator rectifier pack. So what is a regulator rectifier? Now, as mentioned, the output that comes out of this generator is alternating current. So what this does is it rectifies that, because we want to charge the battery and run the systems with direct current, and this is alternating current, AC current. So what this does is it takes the AC current, converts it into DC current, becomes usable power for the motorcycle. Now, what the regulator does is it caps the voltage. So the higher the bike revs, the more voltage we get out of this, and this has to manage the voltage, otherwise your battery will just cook and melt and all your bulbs will blow and all sorts of stuff will happen. Now, when I was at college years ago, they said the best thing you can do when testing equipment with a multimeter is to try and keep the smoke inside of your multimeter. In other words, don't cook it. So if we didn't have a regulator, your wires would produce the smoke, which is what we're trying to keep inside of the wiring and inside of the multimeter. So this just caps the voltage, usually to about 14.5 volts. When these start to fail, you might get a really funky smell coming from your battery. Then you know that it's cooking the battery. So you'll have 15, 16, 17, 18 volts or even higher going through the battery. First signs of that will be bulbs starting to blow, and you'll probably get a really bright dashboard. So I'm just going to show you how we test this. So if you have a look at this one, we've got 3 wires on one side, 2 on the other. As it happens, the replacement one, we've got 3 on each side. And the centre one doesn't matter on this. It's the 2 outside ones that are important. So it's going to be difficult to see, but this has got a plus and a minus on it. So the plus goes to the battery positive, and this goes to the battery negative, or to ground. These 3 are the 3-phase coming from your generator. Now, what does 3-phase mean? You can see we've got a lot of poles here. So as the magnet goes around, it creates the voltage. Every time it goes round, it will create almost like a lattice, and they'll overlap, almost like a plait. So where you'd get 3 bits of rope and you'd tie them over each other, the overlap makes one tight bond, which becomes your usable energy. Otherwise you'll have this fluctuation, big gaps in between it. So to test this, we're going to use a multimeter. Now, those of you who are not familiar with a multimeter, we have a variety of settings on here. This might be difficult to see, but this V with a wavy line across it is alternating current. And then we have another V with a line and 3 dashes, which is direct current. Then we have ohms, and let's see if I can get close to this. We have a symbol here, which is an arrow, which goes to like a flat line. And this is a diode test. Now, all multimeters have this. You don't have to buy a fancy multimeter to get that. We have lots of multimeters here that sit in different toolboxes. This one's from Aldi. Cheap and cheerful, it does the job. And if I take it over to this side, you see it's got exactly the same symbol on there. An arrow that goes to a line. And this one's actually from Lidl. And over at the top here, we've got the same symbol. And this is purely for diode testing. And what it does is it sends a small amount of voltage into a diode, and we measure it out the other side. For this test, I'm going to use my scanner. We're not actually scanning it, but this has a scope and a multimeter feature on there. As we use digital multimeter. And the reason I'm using this one is because it's probably a little bit clearer to see. Actually, it'd be clearer to see if I didn't have the reflection of the roof on it. And this also has a diode and continuity test So if I click on that, we can see the word diode. It's a 4-channel scope, so we're going to use 10 plus 3 and 4. So on your regulator pack, like I said before, you have a plus and a minus. So you stick one onto the plus side, and then you would use the other end and just run this across each terminal one at a time. If I go to 1, you can see we've got 0.62 of a volt there. So if I go to the next one, 0.62, 0.62, oh, 61 there. The figure is not important. What's important is that they're all the same. So this is the one that I took out, the original one, and we've got 3 of those reading the same voltage. Now what I'm going to do with these is I'm just going to swap them round. Okay, so I've swapped these round the other way. So I'm going to put these back onto the positive, and we're just going to do that test again. And if you see, now we have nothing. So if you do this and you get nothing, just swap your cables round. It only works one way round. We swap the cables round. We got our readings back again. So this face value looks like it's okay, and it probably is okay, but something has caused this to melt and break down. So although this is coming up as okay, under load it might be breaking down. Because these components, especially this component, this was about £500, maybe more. I can't afford this and this to fail again. So for the small cost it's going to cost to replace this and save this and save more time and money, we are going to replace it. We're going to replace all these as a unit. So this is the new one. So I'm going to do the same test again. So this is the positive. And if we see, this number is less, it was about a third of what we had on the other one. But you can see that all the numbers are the same. So why is this number lower than the other one? Is the other one faulty? No. This might be a bit difficult to see, but let's see if I can get that to focus. This is an uprated one with MOSFET technology on it. These tend to be stronger and last longer. But because of this technology in there, the readings are different. So don't just assume that you've bought one and the figures are different, that it's going to be faulty or not the right one for your bike. This is specific to this bike. I could have bought the same one as that, but I chose to buy a better one. So I hope this has helped you in testing your own in the future to see if it's viable or it's faulty or whatever. But you don't need an expensive scanner to do it. You can go to Lidl, Aldi, Toolstation, wherever that sells a multimeter. As long as it's got that diode symbol on there, you can run a test with it. Actually, I think this one was about £10 from Lidl, so I will just use it and just see if it gives us the same readings or similar readings. So we have nothing. So swap the leads over. So the figures are way different, but they're all equal. Whilst I've got everything set up here, I'm just going to show you how to test the stator as well. There is a test you can do on this. It's not intrusive, so you can do it whilst it's still on the motorcycle. I've just set this to ohms now. I'm going to do a resistance check on this. Very straightforward. Just stick a probe on one side. We have continuity. And then swap it over. And then if you go into this one, it shows we have continuity across all of them together. So this is in good working order, but because the magnets pretty much exploded, it is attached to everything. You would not get the magnetic dust or all of that off. You can't blow it off, wash it off. It's a magnet, it's stuck. Now if we put this back onto the bike, any of that magnet that catches on here and wedges itself will destroy this. So I can't risk trying to clean this to save it due to the risk of destroying this. If you're in this situation, you can gamble, you can risk it, but because I have to guarantee the job for the customer, the only way I can guarantee is if I replace everything you see here. Now I just want to do a quick talk about these multimeters, the basics, why we have different readings when we measure these. So this is the one with the orange case. So this is a Blue Point one, which was bought through Snap-on. Lidl, Aldi. Now all multimeters are rated. This one here says Cat 3. It says Cat 3 right there. And this one here also says Cat 3. This one has no rating on it whatsoever, front or back. Now these categories are safety ratings. These two have a Cat 3 safety rating. This one I can't confirm what the safety rating is. Now these are also CE approved. Just about CE approval on there. Same with this one, it's in the case. This one doesn't actually have any CE approval, yet this is the most expensive one here. Now if I had an electric car in here, I would be able to use these ones, but definitely not this one, because it doesn't have that safety rating. These go up to Cat 4, so you can get Cat 1, 2, 3 and 4. So these are Cat 3, which is reasonably high for what we want to use it for. If I was doing heavy electrical work, where I was working on a network, you'd want Cat 4. But for what we're doing, Cat 3 is fine. These work with 3-phase as well. So don't assume you just bought something that was expensive or it had a branding on there, which was out of a company like Snap-on. But this is quite old, so this is probably predates the category ratings. It may do the job, but I don't know. It's marked as Blue Point here, but it does have Snap-on the back. Let's just have a look. You can just about see there, so you've got Blue Point here and Snap-on here. Now the way the diode test works, and you saw all these 3 multimeters, including my diagnostic tool, that had 3 different readings. Now a diode test sends small amounts of voltage through a diode and just reads it out the other side. And depending what batteries are in the back of these, what health the battery is, and how they're set up, relates to the amount of voltage that goes through a diode. Let's get that up. How it relates to a diode. Now what it does is it sends small voltage through a diode out the other side, and we see what the current rate is. Now the test we done doesn't necessarily mean that the diodes in here are any good. And the best way to test a diode is to actually remove it and test it whilst it's open circuit. But this has got hard gel in the back, there's no screws to open it up, so you can only do one test, which is the diode test which we were doing. Now I also showed you when I did the diode test, is the diode test only worked one way. But when you test these diodes, you must test them both ways. The reason being is, as you saw here, we had voltage only going one way. But if you get voltage in reverse, then that diode is definitely faulty, because diodes only work in one direction. So always do the test in both directions, and therefore you'll know for sure that one is faulty. But it doesn't always necessarily mean that you've done a diode test and they're all equal, that the diodes aren't faulty. Now when I run the bike up, we can do a volt test across the battery, but we can't see what's happening in here, because we physically can't see it. So I'm going to show you a way where we look inside this without opening it. Now I'm ready to put the components back together. Now, as we had magnet failure, the magnet broke up, bits of magnet are very destructive. They stick to all the ferrous metals and you can't just wipe them off, because if you wipe them, they'll just move around the gear because they're magnetic, they'll just keep sticking to it. The starter gear at the back here, which you can't see, just if I can get, let's have a look in there, there's a little starter gear in there. That had bits of magnet mushed into the gears, so I took that off and blew it off with high pressure airline. So that's clean. But be mindful, if there's any big chunks in there, you are going to have to remove those, because they will just stick to your gears and they'll just keep mashing into each other, and they'll never leave. They won't fling off because they're magnetic, they'll just stay there. Just had old and new running side by side. I don't know if you can see that. So the old one is on the right and the new one is on the left. Yeah, I took the original one off a minute ago and it's still hotter than the new MOSFET one. So I'm going to put them back in and just do a temperature reading whilst it's running. 70 now. The back looks like. Well, it's getting quite warm to touch now, and let's see what temperature we're at now. So the temperature's dropping now, but it reached 72 degrees Celsius. I'm just running for a minute. Right now my hand's warmer than the actual regulator. It's reading 29 degrees at the moment, so less than half the temperature. Not everybody has a thermal imager, but it's a visual way of showing you the differences between the uprated MOSFET and the original regulator. That was getting too hot to touch. So they do get hot, but that was getting hot very quickly. And the original one was reading on the multimeter about half a volt higher to the battery, which means it'd be overloading the battery after some time. So I think it was a wise investment replacing this. Right, do you remember at the beginning of this video we did the generator test? We were looking for AC voltage. We've got a new generator in, it's charging at the battery, so we know everything is good. But I just wanted to show you how to test this with AC voltage, and just to show you what kind of figures you're going to get, just so you have an idea. It was roughly 10 or 11 volts on idle. If you rev it up, that'll just keep going up, 50, 60, 70, 80 volts. So on AC, normally on idle, it's 10 to 12 volts. If you rev it up and down, you'll get higher voltage and less voltage as it goes up and down. And you'll get that across all three phases. You probably couldn't see my hand, but I went through all three phases, and all three phases were between 10 and 12. So I hope that's been quite insightful of how to test the generator, AC, how to test the regulator rectifier, how to open it up. Looking, I mean, this is quite warm now. If I get the thermal imager, actually I won't bother. That's because the engine's hot, but it's warmer there than it is here. I hope it's given you some insight to check your rectifier, regulator, generator before you start spending some money. The amount of times people just go and spend 100 quid, well actually they go on eBay and spend 20 quid, and then they wonder why they're still having problems. It is worthwhile spending the money on buying a decent regulator. These cheap eBay ones are absolutely rubbish. If you can get one which has MOSFET technology, it will greatly increase the life of your regulator. As always, I hope you enjoyed this video. If you did, please hit the like button, the subscribe button and the bell notification so you're notified next time I upload a job. Take care guys.